Okay, in forces chapter, last time we discussed about the concept of the friction, and friction is like a resistive force during the motion of a body when body is moving in any specific direction. So friction always acts in the opposite direction as compared to the direction of the motion of a body, right? And before the topic of friction, we discussed Newton's law, Newton's first, second, third law, and also discuss some questions from the paper. And further, if we discuss about the past papers questions related to these topics. Okay, for example, starting from question number 3. So in this question number 3, it shows distance time graph. So distance time graph is given, and it is the graph for the journey made by a cyclist between town A and town B. And the cyclist leaves town A at time t is equals to 0, and it arrives at town B at time t is equals to 4 hours. So this is the position for town A, and town B is at 4 hours. This is town B. Now we need to find out the distance between the two towns. So from this graphical representation, how to find out the distance between two towns?
So we calculate the shapes underneath the.
Yes, basically we need to use the shapes, and with the help of the shape, we need to find out the distance given in the diagram. So basically, first of all, we are getting a right angle triangle, or we can also select trapezium from this point. So basically, there are two trapeziums. This is the first one, and this is the second one. So there are two trapezium shapes given in this graphical representation. And with the help of trapezium, we need to solve only two shapes. But if we use triangle and rectangle formula, we need to divide into four different shapes. But right now in graphical representation, if you observe that already distance is mentioned on the graphical representation like this. So distance is already mentioned on y-axis. It means you don't need to apply any shapes to find out the distance, right? Because distance is already mentioned in the graphical representation. So this is the value of the distance covered by the body. So what is the value for the distance covered by the body? It is equals to 58 kilometers. So this is the distance between two towns. Next part, determine the time for which the cyclist rests during the journey before he reaches town B. So before reaching town B, from the graphical representation, uh, what is the time duration in which body is in rest state before reaching town B? Okay, before reaching town B, in this whole graphical representation, there is only one position in which body is at rest state. Starting from this point, ending at this point. So these are the 2 points that shows body is in rest state. So starting from 2.2, ending at 3. So there is a gap of zero point 0.8 hours. So there is a difference of zero point 0.8 hours. So zero point 0.8 hours is the time duration during which the body is in rest state before reaching town B. Part B, the speed of the cyclist near the end of the journey is greater than the speed at the beginning. So state how the graph shows this. So according to the statement, it is mentioned the speed of the cyclist near the end of the journey is greater as compared to the speed at the beginning. So from graphical representation, you need to show this difference, that how it is possible from graphical representation, and how we can identify from the given graph that speed near the end of the journey is greater as compared to the speed at the beginning. So from graphical representation, how we can identify this idea that speed at the end of the journey is greater as compared to the beginning. Okay, basically in this graphical representation, initially we know that there is a slope of a graph that shows the speed, because in distance time graph, the slope of the graph always shows the speed. So initially we can mark from the graphical representation that in 2.2 hours body covers 30 kilometer. So basically in the first graph, or in the first like slope, distance divided by time. So if you find out exact velocity, so it is 13.6 kilometers per hour. So initially body is moving with this speed or velocity before reaching this rest state. And after rest state, from 3 hours till 4, so there is a difference of only 1 hour. So if you find out velocity, so distance covered from 30 to 58. So 58 minus 30, this is the distance divided by time is 4 minus 3. So you can see final velocity or speed is greater than the initial. And the same thing they are asking about, that why speed near the end of the journey is greater than the start of the journey. You need to explain this idea with the reference of the graph. So with the reference of the graph, you can solve like the gradient or the slope. So you can see there is a different angle between initial and final graphical representation. So we can explain that the gradient of the graph at the end is greater as compared to the initial. Yes,
I'm sorry, can you repeat why we have subtracted 4 by 3 for
because
the time?
because we are starting from this point. So this point is at 3 hours and we will end at this point. Because before 3 hours body is in rest state. This is rest state. So after rest state, when body starts to move. So from that point we consider the last point. Okay. So from 3 hours body again starts to move. So from 3 hours till 4 hours body covers again distance with respect to time. Before that body is in rest state. Okay.
Okay, sir.
Yes. And from graphical representation, um, as you can see that we marked the graphical representation with some angles. So this is the angle for the first triangle, and this is for the second. So you can see the angle of the second triangle is greater. It means it is more steep. So the simple answer for this type of question is that the graph is more steeper at the end as compared to the start. And calculate the average speed of the cyclist for the journey from A to B. So for average speed, we know we need to count the total distance divided by total time. So total distance is 58. Total time given 4 hours. So 58 divided by 4 is equals to 14.5. Any confusion? Any question? Because it
Sir, can you
hmm,
why have you divided 58 by 4?
basically we need to find out the average speed. Average speed means total distance divided by total time. So total distance covered by the body in this graphical representation is 58. We already discussed. So this is the total
Yes, sir.
distance. And 4 is the value of the time in which this distance is covered. So total distance 58, total time 4 hours. So 58 divided by 4 to find out the average speed.
Okay, sir.
Yes. Question number 6. A cyclist travels along a straight horizontal road. Describe how the average speed of the cyclist can be measured. In your account, suggest what equipment is used, the measurements that are made, and how the average speed is calculated. So now, practically, if you think about the average speed, so for this situation that is given in the diagram, so how we can calculate the concept of average speed in this example. So try to identify that first of all, which quantity we need to measure from this experiment and which instrument will be helpful in this regards. First of all, we required a measuring tape, right? So with the help of the measuring tape, we can measure the distance easily because the ruler is not enough. So without measuring tape, we are not able to measure the distance covered by the cyclist. So one thing is about the measurement, we required measuring tape. And secondly, we also need to record the time, because in speed we have a formula of distance and time. So we need to know about the distance. So distance can be measured with the help of the measuring tape, and for time we can record with the help of the stopwatch. So basically these two um, components helps to measure distance and time. So let's suppose we need to select 2 points. Let's suppose this is point A, the starting point, and this is point B, the finishing point. So when body starts from A and reaches till point B, so during this duration we need to record the time and the distance. So first of all, mark 2 points and measure. Distance using measuring tape. So with the help of the measuring tape, we can measure the distance and then use a stopwatch. Time when cyclist starts from initial point and stop when reaches other point. Then finally we need to apply the formula V is equals to distance upon T. We can also repeat this experiment for several times to get average value. Distance upon time to calculate average speed. So this is the idea how to measure the average speed using the equipments in any specific scenario. And in B part, for part of the journey, the cyclist has a constant negative acceleration. So what is meant by negative acceleration? So how to define negative acceleration? Negative acceleration also called deceleration. And in negative acceleration, we know there is a decrease in a speed of a body. So when a body applies brakes, so definitely speed decreases with respect to time, and that is specific acceleration is called negative acceleration. Decrease in speed. Or in other words, we can say rate of change of rate of change of decrease in velocity. So when velocity decreases with respect to time, so that is called. So this is the idea of negative acceleration. And in the second part, the size of the acceleration is 1.8 meter per second square. Calculate the change in speed of the cyclist in a time 2.5 seconds. So time duration is given 2.5. Acceleration is given. We need to find out change in speed. So which formula helps to find out this change in speed? So basically, there is a very simple formula of acceleration. Acceleration is equals to divided by time. A into t. 2.5, and finally it is equals to 4.5 meters per second. So this is another question. Okay, this is another question related to the same idea. So a girl of mass 35 kg, mass is given, on a bicycle accelerates from rest. So she starts from rest state initial velocity 0, and travels down a slope in a straight line, as we can observe in a diagram how it is moving in a straight line. And the girl does not use the pedals. So she is not using pedals. And also gradient, the slope of this whole path is constant because it is a complete straight line. Now calculate the resultant force on the girl when she is accelerating with this acceleration. So calculate the resultant force on the girl when she is accelerating at this acceleration value. So how to find out resultant force? Acceleration is given, mass is given, F is unknown. So we need to apply formula F equals to ma. Mass is 35 kg. Acceleration is 2.6. 91. So 91 Newton is the force. Now in B part, at first her acceleration is constant at time t is equals to 1. Now at time t is equals to 1, acceleration starts to decrease gradually until she is traveling at a constant speed in a straight line. On figure 1.2, sketch a speed time graph for the girl from when she starts moving until she is traveling at a constant speed. So you need to draw graphical representation. That what will be the graphical representation from 0 till the value they are talking about. So initially they are saying constant acceleration. So constant acceleration means a straight line like this from 0. Then they are saying decrease gradually. So it is not decreasing constantly, it is decreasing gradually. So definitely we need to show a decreasing curve until it starts to move with a constant speed. So this is decreasing. This is constant acceleration. And finally, this part shows constant speed. And second part is state how distance traveled is found from a speed time graph. So if you want to find out the distance from speed time graph, so how we can find out the distance from a speed time graph? So basically, by using area under the curve, we can use the idea of area under the curve to find out distance covered by the body in a speed time graph. Okay, in the same way, we have another question. A car accelerates from rest. So again, car is accelerating from rest. Initial speed 0. And during the first 14 seconds, the acceleration is uniform. And then car reaches speed of 25 meter per second. Calculate the acceleration of the car. Initially, we are starting from rest. Time is equals to 14. And this is the final speed. So definitely we have to apply formula of acceleration. Final minus initial divided by time. 1.78 or round off 1.8 meter per second square. Second part, after first 14 seconds, the speed of the car continues to increase, but acceleration decreases. From 70 to 80 seconds after the start, the car moves at a constant speed of 55. So draw a possible speed time graph. Okay. So we know that initially we starts from 0 and during the first 14 seconds, car accelerates uniformly and reaches value 25. So in first 14 seconds, like 2, 4, 10, 12, 14. This is 14. In initial 14 seconds, car reaches the speed of 25. So 22, 24, 25. So initially car is accelerating uniformly. So definitely there must be a straight line. So this is the initial 14 seconds motion of the car. Then after 14 seconds, the car speed continue to increase, but the acceleration decreases. And from 70 to 80 seconds after the start, car moves at a constant speed of 55. It means finally car reaches 55. So 55 will be 1, 2, 3, 4, 5. This is 50. Then 52, 54, 55. And from 70 to 80 seconds. So 70 is here. So finally, we need to connect these last 2 points. And from 70 to 80, it is moving in a straight line because it moves with constant speed. So finally, this will be a horizontal line constant. So this is the possible graphical representation according to the information given in the question. Okay. Okay, next part is related to the momentum idea basically. So this is the concept of the graphical representation, and they also used to ask this type of questions related to the concept of the graphical representation of speed and speed time or distance time graph. And after this, you can also practice questions by yourself. In this worksheet, you will find other questions also related to speed time graph, distance time graph. So you can also practice by yourself, and you can also ask if you find anything confusing,
Okay, sir.
right? And next time we will also like continue with a new topic because before starting new topic, it is important to practice the questions from speed time graph, distance time graph, Newton's law, etc. Right? So in next class, we will start with a new topic related to the momentum.